Now, today, let's talk about force and motion. So, this is the most important person. This is Isaac Newton. The story goes that an apple fell on his head and he started to think about gravity. We'll probably never know the true story, but it helps us to remember the very important law of universal gravitation. The law of universal gravitation states that every object in the universe attracts every other object in the universe. With a force directed along the line of centers for the two objects that is proportional to the product of their masses and inversely proportional to the square of the separation between the two objects. Here, you can see the formula. It is important to remember how all objects in the universe affect one another. When you look at pictures of astronauts in space, sometimes people say things are floating. They are not floating. They are actually falling around the Earth because they are in Earth's orbit. Every object in space, though, is also pulling against each other. Earth is just very, very large, so it pulls against us harder than any other object near us. So we tend not to notice smaller objects' gravitational fields. Gravity is important to us as humans, though, since we all grew up on Earth. So, even if astronauts are in space, they have to find ways to simulate gravity. For example, this Colbert machine, which helps astronauts stay attached to a treadmill so they can get exercise. Finally, when talking about force and motion, I really like to talk about kinetic and potential energy. Kinetic energy is the energy of motion. Basically, when an object is in motion, it has kinetic energy. Now, potential energy is the energy that an object has based on its position due to gravity, usually. Let's look at an easy simulation to see how kinetic and potential energy changes as a roller coaster moves. Okay, as it goes up the hill, let's make it go up the hill, the potential energy increases because it is higher and farther away from the Earth, so it has greater potential to fall. The kinetic energy is high as long as the roller coaster is moving fast. Eventually, the potential energy becomes lower and lower as the roller coaster becomes closer and closer to the ground, so it doesn't have the potential to fall any further. Let's watch. I always think a roller coaster is the perfect example of potential and kinetic energy. Okay, bye.